Let's begin with the question echoing across the tech world today. Will AI replace me? For any truly skilled developer or tester, the answer is no. Not today, and not completely. But here is the critical distinction. AI will not replace you, a person, but it absolutely will replace the part of your job that are routine, repetitive, and uncreative. Think of AI as your ultimate accelerator for the tedious tasks of coding, debugging, and test case generation. It allowing you to focus on complex problem solving and innovative architecture. Those who master the use of AI tools are not just staying relevant. They are becoming the elite and high leverage professionals of the next decade. I have created a clear and practical learning path that helps you build key AI skills and apply them directly in your day-to-day work in the fields of software development and quality assurance. Let's begin the journey. I invite all of you to the learning path of foundational AI knowledge with generative AI and agentic AI. My name is Rajesh and I am a software test architect in a leading organization. This learning path is your complete structured roadmap, guiding you logically and progressively from foundational AI concepts to specialized in-demand skills. You will master AI in 5 distinct phases. Phase 1, Foundation AI. This phase builds the fundamental skills and theoretical knowledge required for any specialization in AI. It begins with mathematics and statistics. Artificial intelligence is applied mathematics. You need a solid understanding of 3 key mathematical domains. First one is linear algebra for data representation through vectors and matrices. Second, calculus for model optimization via gradients and backpropagation. And the last is probability and statistics for understanding data distributions and model confidence. Next focus area in phase 1 learning path is programming skills. When it comes to programming, Python is the industry standard language known for its simplicity and power. To use it efficiently, you need strong foundations in data structures and object-oriented programming, along with the key libraries like NumPy for numerical operations and Pandas for data analysis. Next one in phase 1 learning path is machine learning fundamentals. Understanding machine learning fundamentals requires knowing the core concepts of building intelligent systems, including the main types supervised, unsupervised, and reinforcement learning. Familiarity with basic algorithms for classification, regression, and clustering, and practical use of the Scikit-learn tool for implementation. Next one in phase 1 is data science basics. Since AI is fundamentally data-driven, mastering the data science process is crucial and encompassing steps like data handling, pre-processing, and feature engineering. Utilizing the tools such as Jupyter Notebooks for interactive development and Anaconda for package management. Big data tools is next core element in phase 1 learning path. For handling massive data sets in data science, you must get introduced to big data tools like Apache Spark and Apache Hadoop. And lastly, deep learning fundamentals. To grasp modern AI, you must learn the deep learning fundamentals by studying the basics of neural networks, which are its essential building blocks. Phase 2 in learning path is generative AI or GenAI. In this phase, we are going to learn beyond the basics. We explore the models that can actually create the new content, such as writing text, generating images, or even producing code. The first focus area in phase 2 is deep learning architecture. Here, we will explore the powerful types of neural networks which makes the AI smarter and more useful. First, transformers are the backbone of modern language models like ChatGPT. Then GANs or generative adversarial networks are great for creating realistic synthetic images and data. And finally, variational autoencoders, which help machines to understand hidden patterns in data. Next one in phase 2 is large language models. To utilize modern AI, we must understand the core concepts, functionality, and the use cases of large language models such as GPT. Next one in phase 2 is prompt engineering. Here we are going to learn how to ask the right questions to AI so that AI can give us exactly what we need. Next one in phase 2 is vector databases. Here we learn how to use smart databases like Pinecone, ChromaDB and VV8 to work with AI data more efficiently. Next one in phase 2 is retrieval augmented generation, RAG. Study this technique for retrieving data from external data sources and combining it with an LLM's output to generate more accurate and context-aware responses. Last one in phase 2 is hands-on projects. Here, apply your knowledge by building and deploying the generative AI applications such as a content summarizer or an image generator. Phase 3 in learning path is Agentic AI. This is the most advanced stage, focusing on creating intelligent systems that can perceive their environment, reason, plan, and execute actions to achieve specific goals autonomously. The first one to learn in phase 3 is Agentic AI Essentials. Agentic AI is built on 3 essential capabilities. That is the ability to perceive its environment, make informed decisions, and take purposeful action. Second one in phase 3 is Agentic Design Patterns. Here you explore agentic design patterns like react, that is reasoning and acting, which enable step-by-step thinking and tool use, along with the chain of thought prompting. Next one in phase 3 is Agent Frameworks. Here you become proficient with agent orchestration frameworks such as LangChain, LangGraph, Groove AI, and AutoGen, which streamline the development of complex multi-agent systems. Next one in phase 3 is multi-agent systems. Here you are going to learn how to build systems where multiple specialized AI agents collaborate to solve complex problems, mimicking human team dynamics. Next one in phase 3 is memory systems. We can build AI that remembers. Short-term memory helps to manage context, while long-term memory stored in vector databases allows to learn from everything it's seen before. Next one in phase 3 is tool use and API integration. You are going to master in this phase on how to give agents access to external tools and APIs, enabling them to interact with the real world beyond their conversational abilities. Next one in phase 3 is development and observability. Here you learn how to deploy the agents into production environment and monitor their performance, debugging the issues with the tools like Langsmith. Last one in phase 3 is advanced projects. At the advanced level, engage with complex real-world problems. For instance, designing an autonomous financial advisor or building an AI-driven research agent capable of interacting with the web. Phase 4 in learning path is responsible AI. The purpose of responsible AI is to ensure that the development, deployment, and use of AI systems are guided by ethical principles. It's an approach that aims to make AI systems safe, fair, transparent, and accountable. Instead of just focusing on what AI can do from a technical standpoint, the responsible AI considers the broader societal impact and long-term consequences of these technologies. Here I listed the key purposes and principles of responsible AI. The first one is fairness and inclusiveness. Fairness and inclusiveness in AI are necessary to prevent the systems from perpetuating or amplifying biases found in training data, thus avoiding discrimination in sensitive areas like hiring, loan applications, or criminal justice. Second one is transparency and explainability. Transparency and explainability are crucial for building trust and enabling human oversight, especially in high-stakes situations. By ensuring that people can understand how an AI system arrives at its decisions. Next one is accountability. Accountability involves establishing clear lines of responsibility for an AI system's actions and outcomes, ensuring it is clear who is responsible when something goes wrong. Next one is privacy and security. Privacy and security necessitate protecting sensitive data collected, stored, and processed by AI systems, requiring adherence to data protection laws and the implementation of robust security measures. Last one is reliability and safety. Reliability and safety ensures that AI systems function exactly as designed and respond safely to unexpected conditions, thereby minimizing the risk of harm or errors. In essence, responsible AI is a proactive framework that seeks to maximize the benefits of AI while mitigating its potential risks, ensuring that these powerful technologies serve humanity in a way that is ethical and beneficial to all. Phase 5 in learning path is AI-powered test automation. This is the last phase and is specifically designed for test engineers. This is the hands-on stage where you learn to apply AI concepts using commercial and open source test tools. In this phase, we are going to explore the tools like TestIm, ApplyTools, and Mabel, which are known for their AI features. Experimenting with these tools can offer valuable insights into how modern automation is evolving and how we can leverage it to enhance quality and efficiency. And also, we are going to gain the practical experience with the key AI testing features listed here. First one is self-healing tests. One of the exciting advancements in test automation is the concept of self-healing tests. This means intelligently adapt to UI changes by automatically fixing broken locators. As your application grows and changes, this approach minimizes disruption and ensures consistent, reliable test execution. Second one is intelligent test case generation. Another powerful capability emerging in the testing space is intelligent test case generation. Using AI test tools, analyze the code structures or user behavior patterns to automatically suggest and create new test cases. This helps the team to improve the coverage and accelerate the testing process. Next one is visual testing with AI. Visual testing powered by AI is transforming how we validate user interfaces. These systems use advanced computer vision to automatically verify the visual layout and appearance of the applications. This ensures that what users see is exactly what they are meant to see across browsers and devices. The last one is incorporate generative AI. Here you learn how to use large language models to generate test scripts, data, and even full test cases based on user stories. We have arrived at the end of this path. This learning path prepares you to move from theory to practice, not just understanding AI. You will be ready to shape it, applying your skills to solve real-world challenges and inspire innovation. Thank you for watching.